Hello and welcome to my presentation on whether peanut butter and apples are complements. My name is Savion Collins, and again, this is a presentation on whether or not peanut butter and apples are complements. So, first slide, here we go. So my final model that I came up with is we have your price of apples equals beta peanut butter, beta average rainfall, beta income per capita, beta banana, and beta population, plus an error term that we did not calculate. Trying to capture all the variables and stuff like this. Again, the variables that I chose here and some acronyms and shortenings for them. Pretty simple. And the reason why I chose these variables, so I chose peanut butter because, again, I suspect that it may be a complement of apples. That would kind of make sense. A lot of people eat peanut butter and apples together, so that's one reason why I chose that one. I also chose average rainfall because rainfall is an important factor, I believe, in crop growth and whatnot. You need water, sunlight, and air, and different things like this for crop growth. And I chose income per capita just to try and, because, the more money you make, the more likely you are to, purchase, different kinds of food and whatnot. So wanted to try and explain a relationship between income and the price of apples. We should suspect that as income goes up, we're going to buy more apples. That would make it a normal good. And I had originally chosen median income for the U.S., but that was a bit funky. There wasn't very much variability, and so I had some problems there. So I went with income per capita instead. I chose bananas because I suspect that they may be a substitute to apples, different kind of fruits. Might be substitutes for other kind of fruits and whatnot. And I also chose bananas because I also wanted to run a regression on bananas and peanut butter to maybe see if there's also a relationship between those two. And moving on, I chose population as a replacement for my time series data in years, just due to some multicollinearity issues with the individual, 1980, 1981 kind of deal. So there's some multicollinearity issues that I had going on there, and I remedied that with a recommendation from a smart man who told me to use population instead of time series data involving the years. Moving on, we're going to take a look at the raw data here. If the internet would work. There we go. Okay. So here it's a bit, funky. You're looking at raw data. You can't really maybe tell too much what's going on. So the population range is about 110 million or so, maybe a little bit less, a little bit more. Income ranges quite widely, again, around $30,000. Price of apples ranges about 60 cents. Bananas around 20 or so cents. So bananas haven't really changed much. Average rainfall, and so going forward, we'll see some of the problems that I had with my data and whatnot. So average rainfall, the variability is quite low. The range is about 5 inches of rain, variability-wise, and so I had some problems there. And then we have the price of peanut butter, which actually ranged quite decently compared to the apples and the bananas. Ranged about $1.10 or so it went up a little bit. And so I was really pleased with how my data came out. We had about 33 or so observations, I want to say, but quite on the low end, but we made it work. Then we're going to go back here to, there we go. Let's see, go back to the next slide. Oh, we're stuck. Okay, so a graphical grasp on the data part eins, and for those of you who don't know, it's 1 in German. So taking a look here, we can see that it's pretty homoscedastic. We have very little, there's not much trumpeting going on, there's not much funkiness looking with the data here. I was pleased with that. We got apples right on the y-axis here, and then we got our variables on the x-axis. Very nice spread here. It's quite, you can say it's a positive linear relationship, and so I was quite pleased with that. Very little homoscedasticity, very little heteroscedasticity. Same kind of deal here. Nice small variances going on here. This one is a bit more funky. Some of the error was a bit more. The price of peanut butter was kind of funky. Still, you can tell there's a positive relationship, and there's a decent amount of homoscedasticity. Moving on, my last one, a graphical grasp part dry, which is 3 in German. We can tell here that there's not much going on here, right? You can tell there's a bit of a positive relationship. It's going upwards slightly, but it's just kind of like plotted on the map quite weirdly. And so there's not much to tell on this one. And again, we'll see that in my data as we go forward. You can tell it's a bit funky, so not very homoscedastic. Moving on, we have our actual regressions here. I don't know how well you guys can see this, but we only had about 2 statistically significant variables, unfortunately. We had one income per capita at 0.059, and then we had bananas were statistically significant. And taking a look at the coefficients here, we can see that income, the coefficient was quite small. Population had a very large coefficient, but it was actually negative, and it wasn't statistically significant anyways. But so as the price of apples goes, or as the population rises, actually by less apples, so that's kind of weird. And then we had a couple other things going on. Banana was quite large, and it was statistically significant, so that was good. And then taking a look at my R-squareds and my adjusted R-squareds, I know this wasn't too much what we were concerned with, but I did explain a decent amount of the variability in the through this model. And again, we only had 2 statistically significant variables, so it was quite unfortunate. Moving on here, we'll take a look at some of the explanations. So for my regression, again, only 2 of them were statistically significant, income and bananas. Went over this. And so the coefficient for income was quite small. When income goes up $1, the consumer will buy 0.0000211 more apples, and the coefficient for bananas was comparatively large at 1.05. So for every $1 increase in the price of bananas, you buy 1.05 more apples, which actually kind of makes sense. That would mean that they are substitutes, and that's the relationship that I was hypothesizing. So it was nice to see that it actually worked out the way that I had hypothesized. Moving on, we did a second regression on the price of bananas to try and, again, maybe explain a different relationship and see what else may have been going on, and try to maybe explain some more statistically significant variables. So here we actually had, again, income at 0.005, U.S. population was our new one at 0.001, and lastly we had price of apples was statistically significant on the regression on bananas at 0.035. And so again, we had a decent amount of small coefficients, and then one quite large coefficient, which actually was what I had made sense of previously. It should actually have been positive. When population goes up, we expect people to buy more apples, not less. And so our R-squares were a bit lower, again, but our goal was not to explain all of the variability, so try and explain a relationship between fruit and peanut butter as complements and something like this. So moving on, we'll go ahead and take a look at the explanations of the coefficients. So when I saw that some of my variables were not statistically significant, I tried a regression on the price of bananas to see if more of my variables would be statistically significant. I got lucky, and one was actually more statistically significant. I believe I said it was population, and so, but this time income was actually negative, which means that as income goes up, we pay less for bananas, or we buy less bananas, so they're an inferior good in this case. And the population coefficient was quite large at 5.27, which again makes sense. Population goes up, we expect people to buy more certain goods. And let's see here, and lastly, for the apples, for every $1 increase in the price of apples, we buy 0.146 more bananas. So they're weak substitutes. Still expecting a substitute relationship here. Again, and then I think I was trying to do peanut butter on this one too, but peanut butter actually was not statistically significant, just by a little bit. But so as the price of peanut butter goes up by $1, let's see here, you buy 0.04 one more bananas. Okay, yeah. So again, so in this case they are complements. No, yeah, anyways, price of peanut butter goes up $1, you buy 0.41 more bananas. So technically, they're kind of weak substitutes. We would expect this to be negative if they were complements. And that was not the case, unfortunately, so it didn't work out so hot in explaining that relationship. And so moving on, we talked about that, and going on to the Durbin-Watson statistic, trying to see whether or not we had some problems with serial correlation. We ran the D-stat, and it came out to be 1.31, which and here for the definition we see that a value near 2 indicates non-autocorrelation, so there's not that much autocorrelation going on. And then going towards 0, you got some positive autocorrelation. So we're just right in the mix there, kind of getting a little bit of autocorrelation, but not too much. And then moving forward, so in this case, the research question that we asked, are peanut butter and apples complements? We found out in this model that they are not complements, they are in fact weak substitutes. This is due to a low positive coefficient. And again, I tried to fix this by running a different regression on bananas, maybe seeing if I had just used maybe the wrong fruit, and it turns out that also bananas face the same dilemma. So in order to try and fix this relationship, we could possibly add in more variables, look at some signs for omitted variables or other data manipulators and stuff like this, or just try and move the things around and see what we can work with, try running different regressions and whatnot. That might be an experiment we could try in the future, and I think that pretty much sums it up. I want to thank you guys for listening. If you guys have any questions, feel free to email me and I can get back to you guys. Since I'm not there in person to answer them right now, you don't have to deal with you standing in front of me or sitting in front of me, I suppose, but that should just about cover it all. I use data from the National Centers for Environmental Information, the St. Louis Federal Reserve, the Bureau of Labor Statistics was where I got a lot of my data on the fruit prices. And some of these variables I didn't use, but we still got the works cited in there just for posterity's sake. That about covers it. So thank you guys for listening again. And this has been a presentation on whether peanut butter and apples are complements using econometric time series data from 1985 to 2017. I'll see you guys when I get back, or never.